couple of you asked about finding correlation by hand. This is from a textbook that I'm using currently. I don't know if you watch this in the future. It'll all be probably be using a different textbook, but it's the same process, okay? So they want us to decide is your relationship between the volume of a person's brain and the intelligence, at least as measured by the IQ test. So they want us to do a scatter plot. It's always good to graph your data. So when I'm looking at the scatter plot, I see a pretty weak positive correlation. The problems ask me to characterize the correlation in words and estimate the correlation coefficient. So it's a weak positive correlation, weak positive association, and let's see, if I'm trying to put a oval around this, boy, I don't know, pretty weak. I would say it's certainly less than R is certainly less than 0.5. If I'm gonna guess, I'm gonna guess 0.3. Okay, I know it's weak. Now they're asking us on this actual problem. They aren't asking us to actually calculate the correlation, but since that's what people asked for, I figured let's do that for this question so we can see how close I am with my guess of 0.3. So here's the completed correlation calculated by hand a long way, and I also included what the built-in calculation was. You can see that I was pretty high with my 0.3, but how do you calculate these? Well, basically what we do when we calculate correlation is we're trying to find like what's the average distance from each of those points. Okay, so it's like that. It's not exactly, but it's all built on standard scores or z-scores. So what we're going to do, the first step is you want to find the mean for the x variable. In this case, we said does brain size determine IQ. For correlation, you could have these reversed, and we'd still get the same answer. When you're trying to do a regression equation, that's when it makes a difference. So what you do is remember how to find the mean. Add up the numbers, divide by how many you have. I think there's 10 in this case. To get the standard deviation, well, that requires you certainly don't want to go back and do all this by hand. But what I would have to do for the brain size is that I have to take the 965 minus the mean, that 1082. Then I'd have to square it, and then you do that for each of these numbers, and that would be the sum of x minus x bar squared, and then you divide by how many, let's see, what is n minus 1, so we divide by 9 in this case, then you take the square root. So that's how you calculate that by hand. You certainly don't want to have to do that. So we're going to calculate the correlation now, and so the formula says we take the sum of x minus x bar divided by this sx, which is the standard score for the x's, and then we'll take this to find the standard score for the y's. We're going to add all those, so you find each standard score, you multiply each standard score, the corresponding pairs of standard scores, and you find the sum of all those, then you divide by one less than what you started with, and that's correlation. That's how you calculate R. So how does that apply to this problem? Well, so to get the standard score, I'm going to take the mean, so for the x's, I'm going to take the number, so 965 minus the mean. Well, the mean for the x's is the 1082 number. Get that answer, then I'm going to divide that by 90.130, whatever, how many decimal places I want. So once I do that, that's where I got the negative 1.29-ish. Okay? Then the next step would be, well, you do that again. Instead of the 965, I'm going to use the 1092, and it's the same process. 1029, sorry. You do that same process. Find the difference, divide it by the standard deviation, Then I'm going to do the same thing with the 1030. 1030 goes there, subtract the mean, divided by the standard deviation. And you do that for each of these x values. Okay, and that's where I filled in that column. Now, to find the z-score for the y's, instead of using the average for the x's, I'm going to use the average for the y's. So I'm going to do 90 minus 102.8 divided by the 14.397 whatever. Okay, and that's where I got that z-score by doing that calculation. Make sure you get your difference before you do the division. And then the 85 goes in next, subtract the mean, divided by the standard deviation. Okay, and I'm just going to do that for each of these y values. Okay, and that's where the z-scores for each of the y values. Notice some are positive, some are negative. That means if they're positive, that's the IQ is higher than the average, and if it's negative, the IQ is lower than the average. Same thing with the brain size. Then we're going to find the product of each of these z-scores. So these correspond to that pairing. So I multiplied those, got that. Multiplied those, got that. Did that for each of these values. Now the next part is you have to find the sum of all those products. So that's what I did. I added up all those numbers. And that gives me the top part of that formula, that sum of the product of the z-scores. And I divide by 1 less than the number of data points, and that's the correlation. And of course that's what the spreadsheet's telling me the correlation is with the built-in function. So I know I didn't make a mistake. And that's what it is by hand. Now what I probably will do on the exam or an quiz for this at some time, I don't know if I will or not, but I have in the past, is I'll give you a table like this and I'll leave some blank and I'll have you fill it in. I'll have you, so you'll have to know how to walk through that or set up a spreadsheet and do that. I don't know for sure that I'm going to do that. I have some semesters I don't. But that's a good potential question. Okay, so hope that helps.